Hello friend, myself Professor Jitendra. Today I will tell you how to solve the question of Maths Honor first year which has come in the examination 2018 of MJPRU University. Question is that prove that three concurrent lines with direction cosine this L1 M1 N1 L2 M2 N2 L3 M3 or N3 are coplanar if determinant value of direction cosines is equals to 0. So to solve this question we have to consider that lines are coplanar and then this condition hold. So let's have a look on the solution of this question. Here I have assumed that let line L such that LMN be the direction cosine of normal to the plane that contains three concurrent lines whose direction cosines are L1 M1 N1 L2 M2 N2 and L3 M3 or N3. Then we have by the condition of perpendicularity, because we have assumed this line L is perpendicular to the plane in which the lines with direction cosine L1 M1 N1 L2 M2 N3 N2 or L3 M3 N3 are contained. That means this line will be perpendicular to L1 because this line is normal to the plane in which these three lines are contained. So L1 will be perpendicular to L, L2 will be perpendicular to L and L3 will be perpendicular to L. Then by the condition of perpendicularity we have, if line L is perpendicular to L1, then we have L into L1 plus M into M1 or plus N into N1 is equals to 0. And in same manner, if line L is perpendicular to L2, then L into L2 plus M into M2 plus N into M2 is equals to 0. L into L3 and plus M into M3 plus N into N3 is equals to 0. Solving last two equation and substituting the value of LMN, calculating from second and third. In first we have this condition. This is our strategy. We can solve first or second equation also, and then we can calculate the value of LMN from first and second. Then we can substitute in third. In same thing we will get here that determinant of direction cosine is equals to 0. So but I have solved the equation second and third here over here. Let's try a look how I have solved equation second and third. I have applied here cross multiplication to solve these two equations. So solving equation second and third by cross multiplication method, we have what is the procedure of solving by cross multiplication method. Procedure is that just select the variable which you want to calculate. I want to calculate here L, so L is the variable, and for some time remove this and just think about the coefficient of M and N and write them in a determinant like this. And if you talk about M, then leave the coefficient of M and then write the coefficient of N and then write of the coefficient of L. So here I have obtained this determinant, and in same manner remove. And if you talk about N, variable N, so you will get here after removing these terms containing N, the coefficient of L, M, N are L2, L3, M2, N3 that I have written here. And after just expanding these determinant of order 2 cross 2, I have L upon M2 minus M2 N3 minus M3 N2, and in same manner I have opened here, and then I have supposed it K. Just I have let it to solve the question, just to proceed in the question. So if I take this one term equal to K, then I can observe L is equals to K times of M2 N3 minus M3 N2. And in same manner, if I take second one terms to the last one terms, that is equals to K, and I will get from here m is equals to k times of n2 L3 minus L2 N3. And if I take third one term equal to the last one term, I will get from here n is equals to k times of L2 M3 minus L3 M2. And substituting these values of m l m n in the equation first, if we substitute these values of element in equation second and third, then we will get 0 is equals to 0, because these values of element are the solution which are obtained from equation second and 2. So this will satisfy equation second and third. So if we put these values of L, M, N into the equation first, then we will get our required relation as I have calculated. Substituting these values of L, M, N into equation first, I have put the value of L, M, N into the equation. I have gotten this expression, and from here I observe k is common from the all terms. So I take k out from all the terms, and here to make the required relation, or I mean to say that to make the required determinant, I have taken here minus out. So it will become, if I take here minus out, it will become minus m1 n2, it will become minus n2 n2 and plus n3, and minus n2 and plus n3. And then if I take k out, k cannot be 0 because k is a constant which is assumed by us. So this expression will be equals to 0 because product of two number is equals to 0. So the k cannot be 0 because we have assumed it. And so this is the only way to put it equals to 0. So from here we have this expression is equals to 0. And what do you think about this expression? This is nothing but the determinant of L1 M1 N1, L2 M2 N2, L3 M3 N3. Because if I try to expand this determinant, I will observe here L1 into M2 N3 and M3 N2, which is same written here, and then minus M1, and I will try to calculate here M1 leaving this row and this column, L2 N3, L2 N3 minus L3 N2, which is same here, and plus if I take here N, and then I can observe L2 M3 minus L3 M2, which is written same here. So I can say this is nothing but the expansion of this determinant, and this was to be proved. So here I have shown that if three lines with the direction cosine L1 M1 N1, L2 M2 N2, L3 M3 N3 are coplanar, then this condition will surely hold. Students, try to solve this question by watching, and try to make your best in the examination. Thank you for watching.